My name is Shiro, and the purpose of today's session is to give you some ideas and show you some best practices on how to secure your own camel routes using Camel's own features. But before we dive deeper into the topic now, let me ask you one or maybe two questions. Who of you already secures his or her camel routes when developing camel projects? Okay. And the next question would be, who of you thinks about security and maybe put some little thoughts into it? Okay, glad some more. Good you are here. Camel makes it really easy to integrate various systems. And if we look at a typical Camel project, well, that's how we start. We look at what systems we have to integrate, what services are there, and then we connect them. And very often, those systems either have different security systems. One is based on Spring Security, the other one uses Apache Shiro, and the next couple ones do use their own independent systems, and we have to integrate it. Or the other problem might be there's no security in place at all. And now we are exposing those services to the intranet or over internet to the world. And we have to think about security, because often these systems contain critical business data you don't want to send to everybody or make available to everybody. And Camel offers about 100 components you can use to integrate your systems, which makes it very easy to expose or use a web service, JMS, RSS or Twitter. And every Camel release brings in new versions and new components. And we have to think about security for all those components. And even if you don't know all those components, you can easily imagine we need security which is independent of the endpoint we are sending the data to or which we are calling. It would be a lot of work if we have to update or change our security implementation all the time. We switch the endpoint from, let's say, web service to JMS. So that's an important requirement we have here. Security needs to be independent of the selected component. And as you probably know, Camel can be configured via XML, or you can use Java Fluent Interface Builder. You can use Groovy or Scala to build your routes. And you can mix those. And security needs more or less to be independent of that. Of course, if you switch from XML to Java, you have to update it a little bit because the configuration is different. But the main implementation should remain the same as before. And since I am a fan of XML configuration, the following examples will be based on XML, but it will work with Java too, that's no problem. Security is available for XML configuration and for Java. So, in order to get started, I've prepared a little demo, and this is a really simple project. The only available route here is, it's HR web service, or employee info service, which gets an employee ID, will forward the message to the HR service, which adds some master data to the message, and then it's content-based routing depending on when you are an employee. The accounting service gets called, which adds your salary to the message. If you are a manager, special accounting is called, which adds your salary and the salary of your whole team, just to differentiate a little bit. So, in order to get started, we need some users here, and since we are talking about security, cryptography is very close, and I will use Alice, Bob, and of course Eve as a hacker. The first two having real employee IDs and are legitimate users to call our web service, and of course Eve tries to attack this and to get the information from the web service. So let me switch to Eclipse. The root itself is very simple. I want you to focus on the security implementation here. So there's not too much going on in it. We have the CXF bean exposed for web service, which contains only our employee ID in this case, and forwards the message to HR, which is a direct route. And this route simply calls a bean, which adds some master data in an employee object. That's more or less it for HR. This value is returned, and then it depends when you are a manager, which is a relatively easy check. If the job title in here contains manager, you are a manager in fact. So special accounting is called, which adds your salary and the salary of the whole team. And the whole message, the whole employee object is returned to the caller. If you are a normal employee, well, only your salary is added, and that's it. I've prepared a couple of unit tests for this, and they all look more or less the same. We have Alice, which calls with her ID, and we have Bob, which uses his ID, and of course we have Eve, and since an ID is easy to get and provides no security, well, she knows the ID of Bob and knows the ID of Alice. And if we fire that up, let me just minimize. You can see that Bob is the orange colored code or printout, and that's the line we are looking for. Bob has a salary of 5,000 and the total is -1, which is the default in this case to indicate it's not set. Alice gets a little bit more information. And of course, Eve gets all the same information because nobody checks whether Eve is authenticated as Alice or as Bob. So there's no security in place. And, well, that's a typical Camel project setup. We don't care about security at first. And if we return back to the slides, this is the point where somebody mentions, what's about security? And very often this happens when somebody already stole the data. So you notice, hey, we have a problem here. Security or critical data is now available to the public, which wasn't available before. And you have to change that. And that's the point where, well, somebody might bring up, hey, let's use SSL. SSL is secure, so it has to protect our data, right? Well, a little bit. SSL, I would even recommend using that for securing your initial web server. So the web service is called via HTTPS and not HTTP. That provides a little bit security. But Eve doesn't even care whether she has to call an HTTP web service or an HTTP web service, HTTPS web service. So SSL doesn't provide any access control, and we have to quickly find another solution. And of course, there is another solution. You would be disappointed if I sent you home right now. So there are some better Camel ways you can secure your data, and we desperately need it. Because if you look at the desired security level we have, or a client expects our routes to have, well, we need something to fill the class up. And even if we add HTTPS to the game here, well, there's only a tiny little bit in the class left. So, Camel provides two main concepts here. One is called payload security, which secures the message content. So if you're talking about securing message content, most of you would probably think about encryption. And that's the biggest part in here, but it's also possible to sign your message and to secure the whole body. But that fills up the class only half, so we need a little bit more, and well, the rest is done by root security, which protects access to our root. So we check whether or not a user or user group is allowed to enter or call the root. Okay, let's get started with payload security, which protects, as I said, the message content. And as you know, Camel simply transports anything. You can put in objects, binary data, XML data, a simple string, as in the sample before. Camel doesn't care and transports it from A to B to C. So this puts a lot of pressure on the payload security features Camel provides. And that's why Camel came up with two different data formats, one being the crypto data format, the other one being the XML security data format. And I'm talking about data formats here because data formats are independent of the component at the end. So if you switch your component from web service to JMS, the data format doesn't care at all. Okay, so let's have a look at the crypto data format, which is a little bit older than the XML security data format. And the crypto data format is really flexible. It simply encrypts or signs any data you can put inside a Camel message. It doesn't simply care about it. And you can use any crypto algorithm you find on your system. So whether it's symmetric, asymmetric, hybrid, crypto doesn't care and uses it. The only limitation you have in here is it affects the complete message body. So since crypto doesn't really care about the content, it's always the message body which gets encrypted or signed. You do not have a way to, let's say, hey, let's encrypt the first part of the body and forget about the rest. That's not possible with the crypto data format. We will find a solution for that soon. So, you all want to know about the code. That's the first overview as an introduction. I will show you some more in the upcoming demo. Crypto needs to know whether you're using a symmetric key or an asymmetric key. So if you're using a symmetric key, well, you have to define a crypto element containing information about this key. You have to define a bean, which assists in loading this key, and that's all the setup work you need to do. If you want to encrypt the message, well, just call Marshall in the part of the root you want to encrypt the message. And if you want to decrypt it, use unmarshal. That's it. Asymmetric looks a little bit different, only a little bit, and it's even easier to use because the only thing you have to specify is a PGP element, which contains either the private key or the public key, depending on whether you want to encrypt or decrypt the message. So it's relatively easy. You don't have to configure a bean which provides key store loading or key loading. PGP handles everything for you. And encryption and decryption simply work the way as before. Call Marshall and unmarshal and reference the PGP element you want to use. That's it. Well, almost for the crypto data format because signatures are left. And as you can see, it looks totally different. First of all, you have to configure a bean which provides access to the key store. That's all for setup work. But if you want to sign your message, you send it to the endpoint crypto sign. And, well, if you look at the body, nothing happens. What happens is you get another header in the message, Camel digital signature, which contains the hash value of your message. So the body is, of course, unchanged, and the message is sent back. And then you want to verify it, so you call crypto verifiers endpoint, and you may be even more disappointed because, well, the only thing that happens is this Camel digital signature header is removed from the message, and there's no other feedback, which means everything went fine, your signature is valid. So no feedback, everything is fine. If verification fails, you get a signature exception, and you have to handle that in your root. So much for introducing the crypto component. We will have a closer look at it in the upcoming demo. But first, let's check out the XML security data format. And as the name implies, XML security, it's for XML messages only. And you can only encrypt messages. There's no way to use signatures using XML security inside Camel. The W3C standard or recommendation for XML signatures is available, but it's simply not available in Camel because I guess nobody ever needed it. So we can only encrypt messages at the moment. And we are limited on algorithm usage. There are some symmetric ones available based on AES, and there are some asymmetric ones available based on RSA. So not too many. A lot of restrictions for one data format, but there's one really cool feature here. And this is you can encrypt specific parts of your message. So what you can do is you can specify an XPath expression which leads to one or more elements or even element content and encrypt only this part of the message. And this brings in another possibility. You can encrypt different parts of the message using different algorithms. So, or using different keys even. So you can encrypt one part of the message for service A and one part of the message for service B. And they only have access to their desired parts. This is a really cool feature, which of course requires, you have an XML message and you can provide an XPath expression leading to the element. Configuration or usage of XML security is a little bit easier. In case you are using an asymmetric key, well, you have to provide a key store parameters element which contains some information about the key store, about the key you want to use, and that's it. Symmetric ones, well, you don't need this element. Encryption and decryption more or less work the same as before. You simply call Marshall with a secure XML element containing some attributes, which I will show you in a minute. And that's it. Your message or your message part gets encrypted. So let's have a look at our initial demo project and let's secure it. The first thing I want to do is, well, we have this employee info service which takes the message, signs it, and encrypts the complete message body using crypto data format. It then passes along the message to HR, which decrypts the message, verifies it, and then the same decision as before is made if your employee accounting service gets called. In this case, we are using XML encryption to encrypt only the salary element, send it back to the employee info service and decrypt it. Special accounting simply encrypts the complete message and sends it back to the employee info service. So the client receives the same plain text message as before. That's an important point here. And in my projects, I always try to do that because the client is now independent of whatever you are doing in the backend. So it's important if you have a web service that you secure it with SSL, because in this part here, at the beginning, before the employee info service, the data is unprotected. So you need to take other measurements into account to achieve security. So let's look at Eclipse. I've prepared another branch for that. No, come on. I don't know what happened to my mouse. No, there you go. Okay. Camel context. Looks a little bit different now. And it even doesn't fit on the screen right now. So the first part that's happening is we want to sign our message. So we are calling crypto sign endpoint, providing some key store information, which is HR store in this case, the alias for the key and the password for the key store. And the sharp here indicates, hey, that's a bean. So bean takes care of loading the key store. And what you can see here, this is a simple factory bean string, so there's no magic in here, which loads the key store and returns it. And that's it. So after this point, the message is signed, the signature header is printed out, and that's it. Now, since asymmetric cryptography is a little bit more interesting here than symmetric, the symmetric part is commented out, but it will work the same way as the asymmetric one. So we have an element up here, RSA encrypt, which provides the public key and simply encrypts the message. The second element is used for decryption later. Normally, you wouldn't integrate that into the same route because, well, you would encrypt your message in one part or in one camel context and decrypt it in the other. But since this is a demo project, I will do both on the same machine and in the same camel context. So the message is encrypted, sent to HR as before, which simply unmarshals the message, prints out a decrypted body and sends it to verification. And just to prove that the signature is indeed gone, the camel digital signature here will be empty. And now begins the really fun part, because now we are talking about XML security, which is a little bit, well, you have to configure some attributes, but it's relatively easy to use because, well, you specify, hey, we want to secure only the element content and not the element itself. So we use an XPath expression here, and what you will see later is that the salary element itself remains, only the element content is encrypted, which is a fantastic way if you want to parse your XML document and, well, verify or validate it against the schema. You enter the cipher algorithm we want to use, and you have to provide a passphrase since we are talking about symmetric encryption here. And well, that's the reason why you don't have to configure any other element. You have to provide a passphrase for encryption and decryption. In a real-life sample, you would normally use asymmetric encryption because providing these passphrases, well, it's a lot of work. And if you want to do it in the asymmetric way, it's more or less the same. You have to provide a key cipher algorithm to encrypt the XML cipher algorithm, and you have to specify where this key is coming from. And, well, that's the element I mentioned before, key store parameters, which simply points to a normal Java key store, which contains our key in here. And as you can see in this example, I've mixed crypto data format and XML security data format. That's perfectly valid and it's possible. The only thing you have to do, never mix crypto and XML security key stores. So use one key store for XML security and one key store for crypto. The reason for this is Camel has from time to time problems loading the key. So if crypto is accessing the key store and XML security is accessing the key store at more or less the same time, I've run into various and very strange problems. So separate those key stores. Makes it easier to handle anyway. Okay, so the final part is to decrypt the message again, and you have to provide the same information as before. In this case, we wanted to decrypt the salary element only. The tests didn't change, so let's fire them up. And what you will see, of course, is a lot of more data because we're talking about XML right now. And, well, the representation of encrypted data is not perfect in Eclipse, so it looks a little bit strange. But what you can see in here is this is the hidden part, that's the signature. Well, the hash value of your signed message, and then it gets encrypted. And that's only a representation problem in Eclipse. It looks a little bit strange, but it worked. So we are decrypting it again, and as you can see, where can you see it? Now the representation is lost. Here, this is the line I want to show you. The digital signature header is indeed gone after verification. And now we're talking about XML. And here begins the really interesting part, because we are encrypting this element's content right here. And as you can see, it's a lot of data, but the salary element remains the same as before, and only the element content gets encrypted and decrypted later. It's more or less the same for Alice. The only thing is, well, the whole message gets encrypted, and as you can see, the root element even is gone. So you have to take that into account if you are parsing your XML data later. If you use XML encryption, you still have valid XML, but all your elements are, of course, gone. And what's about Eve? Well, based on the reason that the first part didn't change, so the message is sent in plain text back to her, she still gets all the information as before. And even pretending to be Alice didn't change at all. So our camel root is a little bit more secure, but we are not quite there yet. We have to do a little bit more. And before we dive deeper into that, well, let's sum up what we've learned so far. We have two data formats, crypto and XML security. And of course, you all want to know, when should I use which data format? Which one is better? It's hard to tell. And well, the first decision you have to make is, do you want to encrypt or sign? Because if you want to sign, we can only talk about crypto data format here. But then it depends on the data you want to encrypt. If you have XML data, and if you need to encrypt parts of the message, use XML security. In all the other points or problems, I would use crypto data format. So only use XML security if you need XPath features to encrypt only selected parts of the message. Crypto is way more flexible and provides much more functionality to encrypt any message you like. So use XML security if you have to, even if I like it more. So the desired security level is, we're halfway there. The class is filling up, but we need to do a little bit more.
Ask a question.
Yeah, sure.
Which one is faster?
XML security is a little bit slower. Simply because, in general, you provide an XPath, and even if you don't provide it, well, it has to parse it a little bit, since we need a valid XML format or valid XML message, which has to be valid after encryption too. So the system needs to do a little bit more. I don't know how much is it slower, but general crypto is much better.
But you still need to encrypt and decrypt. Let's say you have a content filter inside your camel account, right? So you need to decrypt it, goes through the filter, and then encrypt it again. Like you do a lot of encryption, decryption. I'm just wondering how much it affects the overall speed.
The question was about how slow the encryption and decryption or crypto data format process gets. And I've done some testing with the sample project here. An average message took about 0.4 seconds in the first sample without any security. And the sample here, using all this crypto XML security signatures, took about 3 times the time. So it's 1.2. But that's not really representative, because in a normal project, you won't mix up that many encryption and decryption processes. So yeah, XML security, as I said, is a little bit slower, but it's not that much of a difference. And it really depends on your message too. If you have a huge message body, well, there's a huge amount which has to be encrypted and decrypted. Then it depends on the kind of algorithm. Symmetric is faster, as you know. And there are a lot of different parts which influence the speed on that. But of course, it slows down the overall processing. Okay, let's look at root security, our second topic in here. And what we want to achieve here is, well, we want to restrict access to our roots and kick Eve out. So Camel provides here two possibilities too. The first one is Spring Security, which you probably all know, and the second one is Apache Shiro. These are the two components you can use to restrict access to your roots or root parts. And in opposite to the payload security part before, it's a decision you have to make here. You either can use Spring Security or Apache Shiro. You cannot use both. Well, you can, but nobody would, because well, both components offer the same functionality. So the only thing you gain from using both is you have to configure them 2 times. And there's not, well, the security level raises not that much. And so we have to restrict ourselves on using one component only. Spring Security is a little bit older in Apache Camel. And, well, it's all about roles. So you have to create users, you have to assign at least one role to them, and you are more or less set. The only thing left in your root is you need some authorization policy elements. And, well, that's a little bit of configuration work inside XML, but it's relatively easy. And what is left is you need a username password token inside your message header, and Camel verifies which user you are, whether your password is valid, and whether you have the correct role to access the root part you want to access. And that's it. Configuration, in an overview, authorization policy elements. Normally you have more than one. You need an access decision manager as a bean, an authentication manager which provides users and roles. And that's all setup work you have to do. And then you have to decide which roots or which root parts you want to protect. And those parts are surrounded by a policy element which references the authorization policy created before. And that's it. Now Camel takes care of securing this access to this root part. Apache Shiro more or less provides the same functionality. The only big difference is Apache Shiro is more about permissions than about roles. But, well, you have to create permissions, meaning user X is allowed to access root Z and to modify data set, whatever. So permissions are a little bit different than roles from before. Configuration is mostly done in XML. Shiro brings in another ini file, so it's a little bit a mix-up. You have one part in XML, one part in ini file, but yeah, that's the way it is. It's not too difficult. And of course, you had to add another token to your message header in order to provide information for Camel to check your user and your permissions. Configuration therefore consists at least of 2 files. We have this ini file with the username and role information, password information in my case. We have some beans for permissions and some beans for policies. And then we have to protect the root parts again using policy elements. And that's it. So let's quickly jump into the demo. And what I've done here is this demo is based on the initial sample. So there's no payload security in there. The only reason for that is to make it easier to read. What we will do is YAMP info service will make sure, hey, you are a user. So you are either an employee or you are a manager before passing along the message. And then HR checks when you are an employee, whether you are in fact an employee, manager the same thing. The following demo is divided into 2 parts. We have Spring Security first and then Apache Shiro, simply because you shouldn't mix them and it makes it a hell lot easier to read. So let's get back to Eclipse. And I've prepared another branch for that. Okay, we'll start out with the Camel context. And what you can see is I've provided 3 authorization policy elements, one for user, one for manager, and one for employee. User being the most general one, which will be checked at first, then manager okay, and employee depending on not whether you are manager or employee. The authentication manager is in this sample really simple. That's not a real live project because, well, you can see the username, password, and authorities in here listed in plain text, which you of course don't want to do. But Spring Security and Apache Shiro provide functionality to access your LDAP, your Active Directory, your database, whatever you need. Okay, so ignore the exception block for a moment. I will come to that in a minute. And the only thing we have to do is we have to surround the parts we want to protect with this policy elements. And that's done up here in the HR root, in the accounting root, and the special accounting. And what you might have seen is this magic token helper in here. That's a bean that's necessary when you are using Apache CXF. Because what I need is a token. And Apache CXF doesn't pass forward this token. So if I call an Apache CXF exposed web service with a token in the header or a subject in the header, well, this token gets cut off. Apache CXF doesn't forward this at the moment. And I guess they will change that in the future. So what you have to do is you normally would have to use WS security and secure your message header containing your username and your password. Since I'm not talking about WS security, I simply skip that part and I'm passing along those credentials in plain text, which you too wouldn't want to do in a real life project. So all this magic token helper does is it takes this username and password and constructs a subject. There's no verification done at this point whether or not your password is correct or not. It's only passed into the subject, which is then put into the authentication header. And that's it. Camel takes care of the rest in the root, and this is done here. At this point, Camel checks whether or not your credentials are valid and whether or not you have the correct rights for accessing this part. So, let's call our unit tests. And you will see 2 failing unit tests in here. Those are failing on purpose because, well, Eve doesn't know Bob's password and Eve doesn't know Alice's password. So what's returned here is an empty result. The tests for that are different. First of all, if we look at Bob, the token is completely missing, or the user data is completely missing, so there's no token created. And in Alice's case, the password is empty. And what happens is, well, returned is service requires authentication, meaning, hey, the token is not there. I expect the token to check it. And the second one is username and password are not correct. And this is the reason for this big exception block you might have noticed before. This exception handling is optional. You don't need to do it, but I recommend it. The first one is the most important one. Bad credentials, meaning, hey, username and password are not correct for your user. Camel authorization exception happens if the token is missing at all. And the last one is Spring Security only. You can check access denied exceptions. So, for example, Bob tries to access a root part which belongs to a manager, which he's not allowed to do. Well, access denied exception will happen, and your exception policy will contain the user or the role that is required for this part. And that's it. And as you can see, Bob and Alice do work the same as before. They are properly authenticated. They contain the correct information. That's Spring Security. Now, let's have a look at Apache Shiro. The Camel context is a little bit smaller in here because all the configuration is done in Beans XML, which we'll show you in a minute. There's the same token helper because we are still talking about a CXF web service with the same policies. So let's quickly jump to Beans XML, which contains an awful lot of beans now. And what you have to do is you need such Shiro security policy beans containing the Shiro ini. We will look at that in a second. A passphrase in order to secure the message header, to encrypt it and to decrypt it later. Re-authenticate, and you need a set of permissions. You get only one wildcard permission in here, which allows you to read or get employee data, anything in there. The employee part is a little bit different. You have the right to access accounting data, your own accounting data, and the manager has the right to access any accounting data. And that's reflected in the Shiro ini. So that's again a relatively simple Shiro ini because I'm hard coding my users and their passwords in there. But the most important parts are the rules in here. So these permissions reflect the part in the Bean XML. So a manager has the right to access all employee data and any accounting data. And the employee has the right to access all employee data and his own accounting data. These are the permissions we set up in here. And that's more or less it. So if you fire up the test suite, you will see again the same 2 unit tests failing. Because Eve again doesn't know Bob's employee ID password, and more important, she has no clue about Alice's password. There's one big difference in here, and that's the exception block. First of all, the same message is returned. Service requires authentication and username and password are not correct. But there's one important part you should do when using Apache Shiro. And that's the first exception here. Incorrect credentials exception and unknown account exception. Shiro throws 2 different exceptions depending on your username is unknown or your password is not correct. And that's information you don't want to expose to an attacker. So you should catch both those exceptions and neutralize them with a string like that. It's not necessary with Spring Security because there's only one exception in this case. With Shiro there are 2 exceptions. So make sure you catch that. No such header is the same as before. The token is missing. An authorization exception is the same as before. You don't have the rights to access this root part. And there's no possibility to find out which permission is missing. As before with Spring Security, you simply get the information, hey, you don't have the correct permission to access the root. And that's it. So, now we are extremely happy because Eve isn't able to access our root anymore. And, well, again, we have 2 possibilities to secure our roots. And again, you want to know which version or which component is better. It's even more difficult to tell in this case because the features are more or less the same. The configuration, yeah, it's a little bit different, but it's doable. Systems, meaning which backend systems you can attach, LDAP, Active Directory, databases, whatever you like, well, both provide a lot of support for that. And the concepts, well, they differ a little bit. One is role-based, one is more or less permission-based. So it's more or less the same. If you have the possibility to choose among those systems, well, use the system you know. If you have ever worked with Spring Security, keep on using it. The same applies to Apache Shiro. If you have never used any system before, I would recommend Spring Security. In my eyes, it's a little bit easier to use, and there's a little bit more documentation and tutorials available out there. That doesn't mean that Apache Shiro documentation is bad. It's catching up on Spring Security, but Spring Security, in my eyes, is a little bit easier to first start with. Performance-wise, it slows down processing a little bit, but not as much as before with payload security. So in my sample with Spring Security, it hardly didn't change at all. Processing was done in about half a second in comparison to 0.4 seconds without any security. Apache Shiro was a little bit slower, about 0.6 seconds. But, well, that's within the margin of error, so it's too close to call here. And yay, our glass is finally full. So we are now able to protect our data and access to our root. But, well, only if we combine it. So I'm not going to show you that now, but to really provide full security, you would have to combine payload security and root security into one Camel context. And as you can easily imagine, well, your configuration will grow a lot. You've seen it with payload security, configuration gets much bigger as before, and you've seen it with root security, configuration gets bigger. There's no way around it, but, well, you can make your life a little bit easier. First of all, limit yourself. You would only use one component anyway, either Spring Security or Apache Shiro, but I recommend limiting on data formats too. So normally start with the crypto data format and only add XML security if you really have to. And of course, protect critical roots only. Do not protect everything just because you can and the technology is cool. Protect only the parts you have to. And think about this early. Normally, security tends to be implemented at the latest possible minute. So 5 minutes before the system goes to production, we think about security and add a certain layer, or maybe 10 minutes. We add a certain layer around it and hope for the best. Don't do this with Camel security. Well, don't do it with security at all. But think about security in the beginning, identify the root parts you want to secure, and add it later. Make your roots work first without security and add security then. Because then, if routing fails, you know it's the fault of security and you know where you have to look at. And even if it's a lot of work and a lot of configuration and a lot of stuff to think about, well, we have to do it. Camel transports critical business data. We make critical business systems accessible to a whole bigger user base. So we have to protect our messages and we have to protect our roots and have a lot of fun with that. Thank you. Everybody happy? No questions?
I take it your example of password-based authentication was just that example. You have all the authentication mechanisms of either Spring Security or Shiro available. So if you want to do mutually authenticated TLS or something like that, then you can do that as well.
The question was about security mechanisms and which are available here. Well, yes, more or less everything is available. You have to provide a token or a subject in Spring Security's case, and how you create that is totally up to you. So my sample was really just for a sample project to make it easy to understand, but you can use anything you like in there, as long as you create a token in the end.
What's under the covers for the cryptography
XML security uses Apache Santuario, the Apache XML security implementation, which is a lot bigger than the data format you have available in here. So Santuario provides XML signatures, but it's not available in Camel. So it would be easy to activate it, I guess.
What about the other one? What about crypto?
I don't know the exact name, but Bouncy Castle is shipped with it as provider, so you can use that.
CE with the bouncy castle.
Yes, I think about it.
provider. Okay, one more. With your key store, you had the key store password in that config file. That would never fly in a lot of IT shops. So is there a callback mechanism or something that you can?
Yeah, you can. That's another part of Camel security. You can externalize your configuration, and you can use JSIP, the Java security. I don't know
Yeah, JSIP.
whatever it's called. And you can use that to secure your password. So you don't have to provide your passwords in plain text in your configuration files.
Is there any HSM support instead of using software?
Oh, I don't know that. I've never heard of it.
You'd want it. I mean, that's a pain point, really, is the private key passwords is, you don't want to have it really anywhere, not even hashed or encrypted or nothing. You want to call back. So that's just a good requirement to think about.
Yeah, in general, this security stuff in Camel is, well, it's not that used as often as you would like to have it used. So they are open to feature requests and stuff like that. Just send them a message.
Other than your helper classes, all the Java code here was untouched in all of your examples? You didn't
Yes.
have to modify it?
Now, the only thing that changed in the examples was for Spring Security in Apache Shiro, I extended the unit tests to provide this username and password. The beans itself were completely untouched. I added the token helper to create the token, and that's it. Yeah, the sample project is available on GitHub, so if you want to have a look at it, there are all branches available. And the slides will be published, of course. Okay, thanks again.